So today we're going to cover section 2, and we're going to talk about arcs and their measures. So we're going to be finding arc measures. So the first thing we need to do though is define what a central angle is. A central angle is an angle whose vertex is the center of the circle. So in this pink circle here, I've got my center, which is point B, and I can say that angle ABC is a central angle. A central angle, the sides of the central angle are radii. Let me do this in a different color. So a central angle is formed by two radii meeting at the center and forming a central angle. So the sides of a central angle are radii. Now, let's say I put in another point just to show you some more central angles. So let's say I add point D here. Another central angle, now that I've added another point onto my circle, I could say angle DBA is a central angle. I could also say angle DBC is also a central angle. Notice all of these central angles have B as the middle letter, indicating that that's the vertex, which is also the center of the circle. So the radii they form the sides of the central angle.
Cynthia, for a second I thought you needed glasses.
So an arc is a broken part of a circle. We have minor arcs, which are arc measures that are less than half of the circle. We have semicircle arcs, which are exactly half of the circle. And major arcs, which is an arc that's greater than half of the circle. Arcs are measured in degrees. So when it's a minor arc, this will be less than 180 degrees. When it's a semicircle arc, it will be exactly 180 degrees. And when it's a major arc, it's going to be greater than 180 degrees.
Is the circle being 360?
What an arc looks like is this. So if I have a circle, and if I add in some points, A and B, the arc is this part of the circle. So it's the outside edge. That's the arc. And if I wanted to name an arc, I would put the two capital letters that bound the beginning and the end of it, and then I put a little curved, something that looks like an arc on top. So that would be an arc. So we're going to see that next. On the next slide, here is a circle. We're given that DC is the diameter. And we're also told that arc AC is a minor arc. So this is arc AC, goes right here. DAC, and again, the order of the letters tells us the direction to go. So for this one, DAC, I would start here, go to A, and then go to C. Okay, this is the semicircle arc. And that would be 180 degrees. Now, I can't assume that ABC or AC is 90 because I don't have a right angle mark there. So I can't tell how big arc AC is yet. Or if I can't tell the measurement of ADC. So for ADC, this major arc, I would start at A, I would go to D, and then I'd circle around. And notice that I've just gone more than 180 degrees. So a major arc is greater than 180 degrees. When we name the semicircle arc and the major arc, we're going to use 3 letters to name it. When I'm naming my minor arc, I can name it with 2 or 3. I don't need 3 for the minor. So for example, if I were to put another point on here, in between A and C, and let's say I call this E, I could also call this minor arc A, E, C, and name it with 3 letters, or you could just name it with the 2. Now we're going to find the measure of the arcs. So the measure of an arc is equal to the measure of its central angle. So for example, right here in this pink circle, I have this central angle measuring 50 degrees. So then that tells me that this arc measure is also 50 degrees. Now, DC is the diameter. So in order to find CAD, you can see that it goes from here to here. And this is on either side of the diameter. So this would be your semicircle arc. So it's 180. Then to find ACD. So to find ACD, what I can do here is I'm going to start at A, I'm going to go to C, and then I'm going to go around to D. Now to find its measure, from A to C it was 50, and then now from C to D is the semicircle, so I add the 180, so this arc measure is 230 degrees. So this little M here in front is indicating that it wants us to find the measure of that arc. And again, here's the symbol for arc. It's that little curve over the top of the letters. So whenever you see M and then an arc they want you to find how big it is. They want it in degrees. So our next vocab is adjacent arcs. We had adjacent angles before this. Remember, adjacent means next to. So we're going to be next to each other, arcs that are next to each other. So they're going to have arcs that have exactly 1 point in common. So they can't overlap. So for example, I could say that arc TQ here is adjacent to arc QR. It's right next to it. So TQ and QR would be an example of 2 adjacent arcs. I could also say that QR is also adjacent to SR. And the order that you're writing these letters doesn't matter. So again, we'll put the arc picture on top. Notice by definition they have exactly 1 point in common. So see how they both have Q's? Here they both have R's. An example of 2 arcs that are not adjacent, so not adjacent, could be TS and QR. These are not arcs that are next to each other. So before Christmas break, we learned about the segment addition postulate and the angle addition postulate. Now we're going to learn the arc addition postulate. So prior to this, we learned, I abbreviated as AAP and SAP. So this was angle addition postulate. And this one was segment addition postulate. Now we have another one, and it's called arc addition postulate. So here it says the measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. So all this is saying is if I wanted to find out how big ABC was, and I knew what this one was, AB, I could add it to BC, and then that would give me ABC. So they have to be 2 adjacent arcs in order to do this. They have to be right next to each other. Congruent circles and arcs. So last week we learned that congruent circles were circles with equal radii. So for example, if I have two circles here. I draw them. Soon as I label it with the same radius length, I know that these circles are congruent. These would be congruent circles. So if I have the same radius length and the same central angle measure in both of my circles, and let me add some letters here. Say this is LM, and I'll call this AC. I could say that arc AC is congruent to arc LM because they are congruent circles and they have congruent central angles. So what we're looking for is two circles that have the same radii length. Now, if I were to draw another circle here and give it a different radius length, so let's say I told you this circle has a radius of 5, still same central angle, and let's call this BN. BN would not be congruent to AC because these are not congruent circles. Think of taking a piece of string and laying it here, and you could see that the measure or the length of that string would not be the same. Yes, right? So they want us to name two minor arcs from this picture. So I've got a minor arc here, that's RA. Now, the order of the letters doesn't matter. I could either call that RA or AR. I've got another minor arc right here at RC or CR. So that would be the minor arcs. And I can get away with naming my minor arcs with only two letters. Next, we need to name two major arcs. Remember, the major arcs need to be greater than 180. So it only wants me to find two. So I could go here and I could say start at A. Let's see. See if the blue will show up. I could go from A to R to D. So I could say a major arc would be ARD. If you didn't want to use the R, you could have said ACD. I could have gone the other way. I could have said DRA. Either way. I could have started at R, or I could have started at any other letter. It didn't matter, as long as I went greater than 180. So those were the major arcs. Now for the semicircle arcs, we have our diameter here, which is AC. So my semicircle arcs would be ADC, or you could name it as CDA. And then the other side would be the ARC, or the CRA. These would be the semicircle.
Can't you just do AC?
Yes. Generally, though, when you name a semicircle or a major arc, you need 3 letters. All right, now we need an acute central angle. Now, the only one that looks like that it's less than 90 is this one right here. So I'm going to say AOR. So my acute is AOR. And then the congruent arcs, the only thing I know for sure are the two semicircle arcs. So I would name these things here, ARC and ADC. Those would be the two congruent. So the two semicircle. I can't assume that anything else has the same measure. It wants me to find the measure of WX. Well, WX is right here. I don't have a central angle, so I need to sort of think of this like a puzzle. So I have a central angle measure here of 30 degrees. So then that's going to tell me that this arc measure, if this one's 30, then this arc measure along here is 30. And then over here, I have an arc measure of 50, which tells me this central angle is 50. YT, this is my diameter. And if I know that these three angles here are on the side of the semicircle, I could figure out my missing piece right here by doing 180 minus the 30 minus the 50. And that missing piece is going to be 100. Which gives me the arc that I was looking for. So 100 degrees. Now I've probably filled in quite a bit of information. Let's see if I can answer the rest. So it wants angle WOT. So WOT is this right here, and I've already labeled it with 50. Then arc XYT, which is over here, X to Y to T. I'm going to add 30 plus the semicircle for a grand total of 210. I'm applying that arc addition postulate. And then the last question wants angle YOT, which is right here. It's the semicircle, so 180 degrees. So sometimes when you're asked to find or fill in stuff like this, sometimes it helps to start filling in the picture instead of trying to answer it question by question. So again, treat it like a puzzle, fill in all the missing pieces, then go back and answer the questions. So your homework is 10-2. It's due tomorrow. Tomorrow we will reinforce 10-1 and 10-2 and do some worksheets for some extra practice.